Give it to him right now.
This is a easy section. Again, this is all review for you. Real numbers. Real numbers, the abbreviation for real numbers is an R with two lines like that. So if you see that, if something is real numbers, all that means is it's every possible number. It can be fractions, decimals, whole numbers, negatives, square roots, cube roots, squares. So in your assignments, sometimes they say find the real number. All that means is it tells you it could be anything. If they tell you to find the integer, that narrows it down for you. Do you remember what integers are, or easier, what integers are not?
Fractions.
They're not fractions or decimals. So, if they tell you in the directions find the integer, that tells you that you're not going to get a fraction or a decimal. If they say find the real number, that means you can get anything. Okay? The integers, if you represented it as a set, it'd be dot, dot, dot. Like that. So that's the set of integers. The abbreviation for integers, anyone remember this from
I.
last year? You would think it's I, but it's not. Integers.
Isn't it T? G.
Integers.
Z.
Z. I don't know why they made integers a Z, but they did. Okay? So a real number line just means you would have a number line. Oops. And you could have any number. It could be in a fraction or decimal spot. Okay? If it's an integer number line, your dot would be only on the numbers. Negative, positive, I don't think I got to go over that. I sure hope anyway. If you had on a number line dots on these two numbers, do you know what they're called?
I forgot.
What are the two numbers the dots are on?
-2 and 2.
What are they called?
The same.
They're not the same.
Equals.
No. Huh? It has to do with absolute value. If one number is positive and the other one's negative, they're called what? No, that's when you flip it.
Did you say reciprocal? Yep.
7 and -7 are opposites. There you go. Opposites.
I was going to say that.
So all it is, one's positive, one's negative. Okay, everyone flip their iPads upside down so you're not looking at that. Otherwise, then I don't have to lock you in. Okay? That has to do, opposites has to do with absolute value. Absolute value, the actual distance, or well, I can scroll down for it, I guess. Absolute value definition is it's the distance from 0. Distance can never be negative. So that means absolute value will never be negative. Okay? So if you had the number -5, how far is that from 0? 5 units. So that's why they get the absolute value. The absolute value of -5 is 5 because it's 5 units away from 0. The absolute value of 6 is 6. Remember, sometimes people get this confused. They think this means to change the signs. It doesn't. It just means how far is it from 0, which means whatever's inside is going to be stay positive or turn positive because it just represents a distance. Velocity. They should have had speed on here too. Speed is how fast you're going. Speed and velocity are basically the same, except one difference. Speed is always positive. So that means whatever your speed is, it's the absolute value of it. Velocity can be negative. So if something's going 60 miles per hour, that's their speed, like in a car. Okay? The velocity, depending on the problem, the velocity could be 60 miles per hour or negative 60 miles per hour, depending on the problem. Anyone know why it would be a negative? You're close.
Falling?
Going down, right? Negative is if it's going down. And positive if it's going up. Okay? So really, today all we're doing is greater than or less than, comparing numbers, and then finding the absolute value of numbers.
Hey.
So comparing on a number line, we don't have to draw the number line. -7 and -3. Is -7 greater than or less than -3?
Less than.
Less. Remember, when you're comparing negatives, the bigger one is actually further to the left, so that's actually smaller. So -3 is greater than. So remember, the big part is on the big number, the little part is on the little number. Ordering. I think there's like 4, 5 problems where you have a list and you got to put them in order. You can use calculators. It's always easier to make them decimals, I think. You can make them all fractions, all decimals, but 4/5, you just take top divided by bottom would be -0.8. 3 divided by 2 is 1.5. So when you put these in order, increasing order means you start with the smallest. So obviously the smallest is either this negative or that negative. Which one is the smallest? -1. So you'd put that first. Then it'd be this. Don't put what you changed it to, put what the original is. Then of these two, 1.5, 1.8, would be the 1.5. You guys know how to compare numbers, right? I'm kind of skipping over that. The 5 is less than 8. So don't put the 1.5, put the 3/2, and then the 1.8. This is off the track, but I just thought of this in case they have any of these on here. On the test I corrected, some of you had it was maybe just going too fast or something. When we had to evaluate these, XY is not 23. Because remember what this is mean when they're against each other? You got to multiply them together. It's 2 times 3, which is 6. Okay, there was a few of those on the test. We'll go over that tomorrow, but I just thought. Opposite of -4 is +4. Okay, so then the absolute value, again, in this one, what could you put in for that x to make this true? 3 and -3. Now, throughout the year, if you ever have an answer that is both positive and negative, you can write it twice like this, or the shortcut is just to write it like that. That means it can be a +3 or a -3. Either way you want to write it is fine. So, what could I put in here to make that one true? Huh? You would have to put it outside, but there's nothing missing outside. So what could I put in for x to make this true?
-4 plus 2.
-4 plus 2 turns out to be -2, which turns into 2. So that still doesn't equal it.
Mine makes sense.
Yeah, yours makes sense, except there's nothing missing out there to put anything in. So what can you put in for x to make that true? Someone's thinking it, they're just not saying it. put 2 in, absolute value of 2 is 2, so that still doesn't equal negative 2. 4 minus 2 is 2, which equals 2, so that still doesn't
2
work.
minus 4.
2 minus 4, we already tried that, remember?
Negative 4 minus 2?
We never did 2 minus 4. It's not.
So that still turns out to be 2, which doesn't equal negative 2.
Okay, let's tell them it's not.
Huh?
With multiplication?
No possibilities.
Is that what you're saying? Can't be done. There's no solution.
You've been here all day trying to
There's
solve
nothing you can put into an absolute value that'll equal a negative. So sometimes they throw these in here. When we're solving these, we're not solving them today, but eventually we will. And you can go through the work and solve it and come up with an answer, but if you checked it, it wouldn't work. So an absolute value can never equal a negative.
I was good.
Okay? True or false? The expression the absolute value of A is sometimes greater than A. False? Can you give me an example? So I'll just pick a number. The absolute value of 4. Could that be greater than 4? Pick another number. The absolute value of negative 3. Could that be greater than negative 3?
Yes.
Yes. See, all they're doing is they're using the same number, but one of them has an absolute value, right? So here it's not, but here it is. So sometimes it is. If they ever give you letters like that, just try a couple of examples. Pick any number. So here, expression negative absolute value of A, so pick a number. Is it always less than the number inside?
No.
So there it is, right? Because the negative's outside. So this would turn to 3, but the negative would stay there. That is less than 3, right? If I chose a negative number then, this would change to 4, right? But the negative would stay there. Is that less than negative 4? No, it's not. So it's not always, it would just be sometimes. So this would be false. Is that the end? Must be.
That's good.
Okay.
You're the end.